Let's get started on your Algebra 2 notes over compound inequalities. This is meant to be a review. So hopefully you remember a little bit about compound inequalities from Algebra 1. So first and foremost, what are compound inequalities? Well, compound inequalities are a result of two or more simple inequalities combined by the word or by the word and. So whereas yesterday we dealt with algebraic inequalities, just a simple inequality, today we're going to be dealing with multiple inequalities together, and we're going to be graphing both of them together on the same number line. So these are our two types of inequalities. So let's look at this one over here, this OR inequality right here. So an OR inequality, it's a combination or union. Here's our symbol right here. This is our symbol for OR. It's a union of solutions. The solution occurs when either of the inequalities is true. So it's kind of like when I ask my kids, do you want an orange or an apple? You can choose. Either works, an orange or an apple. So when you have solutions like this, x is less than 1 or x is greater than or equal to 5, either of those would work. They don't both have to work. So when I graph these two inequalities on this number line, this x is less than 1, I've got it graphed in red. X is less than 1, that's right here. Or x can be any number greater than or equal to 5. So closed dot at 5, shaded to the right. That's our solution, and that's how our graph would look. Okay, so we're graphing multiple inequalities on the same coordinate plane. So that's the OR compound inequality. What about an AND compound inequality? Well, that's an intersection of solutions. Solutions are between two quantities. Both inequalities are true at the same time. That's an AND inequality. They both must be true, okay? So let's look at this example. I have x is greater than or equal to -2 and x is less than 7. So let's graph both of those on this coordinate plane. X is greater than or equal to -2. So I've got a closed dot at -2 and I'm shading to the right. So it goes all the way to the right. And x is less than 7. So I've got an open dot at 7 and I'm shading all the way to the left. Well, your AND inequalities, because both of them must be true, your solution is where those two lines overlap. Okay, it's the overlapping shaded region, which means when I graph it on my number line, I'm just going to have a closed dot at -2 and an open dot at 7, and my solution set is everything between those two quantities. Okay, so that's how I would graph an AND inequality on my number line, or an AND compound inequality. What I love about AND compound inequalities is this right here. This compound inequality, the AND inequality can be written like this, okay? And I'm actually going to, instead of reading it from left to right, I'm actually going to say, okay, your smallest number is over here, -2. Your largest number is on the right, and x is in between. Because x is going to be greater than or equal to the smaller number, and it's less than 7. Because it's greater than or equal to 2, that tells me I'm going to have a closed dot. Because it's just less than 7, that tells me I'm going to have an open dot, and then x is everything in between. Okay, so let's move on. So how do we solve AND inequalities? Let's look at this first little scenario. So obviously I've got two inequalities and I've got to solve them. 2x minus 1 is greater than 3. So let's solve for x. I'm going to add 1 to both sides. So I get 2x is greater than 4. And then I'll divide both sides by 2 and I get x is greater than 2. So x is greater than 2, that's one inequality that my solution must satisfy. And this other one over here, I'm going to solve for x. I'm going to add 1 to both sides, so I get 2x is less than or equal to 8. And then I divide both sides by 2, so I get x is less than or equal to 4. So now I've got two inequalities. I'm going to graph both of them, and I'm actually going to do them in different colors. So let's graph x is greater than 2. So x is greater than 2. Am I going to have an open dot or a closed dot at 2? I'm going to have an open dot. And which way am I going to shade? To the right. Now I'm going to choose a different color here, pink. X is less than or equal to 4. Open dot or closed dot at 4? Closed dot at 4, and I'm going to shade to the left. Because my solution set must satisfy both inequalities because it is an and inequality, then my solution set is the overlapping shaded region, which means between -2, open dot, and +4, closed dot, everything in between is where they overlapped. Okay, so I've got 4 right here, 2 right here. X is everything in between. It's less than or equal to 4. It's greater than 2. Okay, so I can write my solution like that as well. So let's move on to number 2. This is another type that you'll see. So now, a lot of times you'll see the and inequalities written like this, where your variable is in the middle, and you've got your inequality symbol right here and right here. Okay, so the goal is to get x all by itself on the inside of those two inequality symbols. So I'm going to work this out the same way I do in my Algebra 1 classes. So the first thing I'm going to do is, to get x all by itself, is subtract 3. Well, I'm basically solving both of these inequalities at the same time. So I'm going to subtract 3 from -5, and I'm going to subtract 3 from 11. Okay, it gets subtracted from everything. So 11 minus 3 is 8. And then I've got greater than or equal to, I'm left with -4x, greater than -5 minus 3 is -8. So now I need to divide by -4 to get rid of the coefficient of x, which means everything gets divided by -4. And I'm left with x on the inside. 8 divided by -4 is -2. And I'm going to flip over here. -8 divided by -4 is +2. Because I divided by a negative, what must I do to my sign? I need to flip it. Right there and right there. Okay? So now we flipped our sign. And now let's graph both of these inequalities on this number line. I'm going to do the same thing I did on the previous example, where the first thing I'm going to do is I'm going to graph this right here. I'm going to rewrite it. X is greater than or equal to -2. So x is greater than or equal to -2. Open dot or closed dot at -2? Closed dot at -2. Everything to the right is what's greater than -2. Now I'm going to graph the other one. X is less than 2. X is less than 2. Open dot or closed dot at 2? Open dot at 2. And I'm going to shade to the left. Okay, so what's my solution set? It's the overlapping shaded region because this is an and inequality. It must satisfy both inequalities. So open dot at or closed dot at -2, open dot at +2, x is everything in between. Okay, so this is how you'll see and inequalities in a lot of situations. So those and inequalities, I say they're like connected, right? You've got endpoints and they're connected. But sometimes you might get some that look like this. Let's move on to number 3. So this is written the same way. So again, we want x all by itself. So what do I need to do? I need to subtract 2. It gets subtracted from everything. I'm left with 2x in the middle. -4 minus 2 is -6. 6 minus 2 is 4. And now I need to divide everything by 2. Okay, there's my symbols. So now let's do this. -6 divided by 2 is -3. 4 divided by 2 is 2. So this is really interesting. So I've got an inequality. I'm going to rewrite this. This one right here is what I'm going to rewrite. X is less than -3 and x is greater than 2. Well, let's think about this. x is less than -3. What would that look like? Open dot at -3. Everything to the left is what is less than -3. What about x is greater than 2? Open dot at 2, shading to the right. So my solution set for an and inequality is the overlapping shaded region. Do I have anything that overlaps? I don't. So what would my answer be? No solution. There is no solution. There's no number that would satisfy both inequalities. They must satisfy both inequalities. And I don't have a number, so I have no solution. All right, let's look at the next type of scenario that you might see with an and inequality. So again, it's written like this, but I need to simplify what's on the inside of those two inequality symbols. So I'm going to distribute this 4, and I get 4x plus 8 is greater than or equal to 24, and then I'm just rewriting that. And now I need to get rid of the 8. What do? I subtract 8 from everything. 4x greater than or equal to 24 minus 8 is 16. 4 minus 8 is -4. And now I'm going to divide everything by 4. I'm still left with x greater than or equal to 16 divided by 4 is 4. -4 divided by 4 is -1. So now I have my solution, and that's fine if you just want to leave it like that. But when I'm graphing, I like to rewrite it. I like to at least rewrite what's on the left because I really like my variable to be on the left when I'm graphing. So x is less than or equal to -1 and x is greater than or equal to 4. So let's graph this on our number line. I'm going to graph it on this top number line. And the first thing I'm going to do, I'm going to graph it, this first one right here in green. So x is less than or equal to, oh, wait a second, did I do that right? I sure did. X is less than or equal to that won't work. We're on number 4, and this is just another type of problem that you'll see. So again, we're trying to solve for x. So the first thing I need to do is get rid of the parentheses. So I'm going to do that by distributing this 4 into each term on the inside of parentheses, and I'm going to get 4x plus 8. And then I'm going to rewrite everything else that's in this compound inequality. So that expression is greater than or equal to 24, and I'm actually going to read it backwards. It's also greater than or equal to 4. So now I need to solve for x by subtracting 8. What do we subtract 8 from? Everything. So 4x is greater than 24 minus 8 is 16. It's also greater than or equal to -4. And now we're going to divide everything by 4. And we get that x is greater than or equal to 4. It's also greater than or equal to -1. So I'm going to graph both of these inequalities on the same coordinate or on the same number line. So the first thing I'm going to do is rewrite this one right here. I like to have my variable on the left, so x is greater than or equal to -1. Remember, it's the same information, we're just kind of writing it differently. So x is greater than or equal to -1. What is that going to look like? Greater than or equal to -1, I'm going to have a closed dot at -1. Greater than or equal to would be shaded like that. So now I'm going to change colors here, right here, and now I'm going to graph x is greater than or equal to 4. What is that going to look like? Well, it's going to look like this right here. I'm going to have a closed dot at 4, greater than or equal to 4, looks like that. Now remember, your and inequalities is the overlapping shaded region, where they're both, because the solution to this compound inequality is when you plug it into each of these inequalities, meaning you plug it into 4 times x plus 2 is greater than or equal to 24, it's true. That number is true. If you plug it into this one over here, I'm going to kind of read it backwards. I'm going to change colors here. Right here, 4 is less than or equal to this expression. It's going to hold true in that inequality as well. So where's the double shaded region? It's right here at 4 and greater. So it's x is greater than or equal to 4. That's your solution for this type of compound inequality. So just keep in mind the word and. It has to satisfy both inequalities. Any number that's equal to or greater than 4 will satisfy both of these inequalities. Let's move on. What about when we're solving or inequalities? It could be this or that. Well, let's solve each of these simple inequalities, and we're going to graph it on this number line. So this is kind of the typical one that you see. Let's solve for x in this first one. I'm going to do that by moving my variable to one side, and I get x plus 3 is less than or equal to negative 2. And then I'm going to subtract 3 from both sides, and I get x is less than or equal to negative 5. So what does this look like? Negative 5 is right here. Closed dot because of that or equal to, right? That line underneath my inequality symbol, less than or equal to. So we're including negative 5 as a solution in this inequality. Less than would go this way. So x is less than or equal to negative 5. And I'm going to change colors when I solve this next one. Now let's solve the next one. I'm going to move my variables to one side. I don't need to simplify either side. So I'm going to move my variables. I get negative 6x plus 5 is less than negative 7. What do I do now? I'm going to subtract 5 from both sides. Negative 6x is less than, I'm moving it over a little bit, negative 12. Now what do I do? Divide both sides by negative 6. And what do we do when we divide by a negative number? We flip our sign. So x is greater than negative 12 divided by negative 6 is positive 2. So now let's graph this on our number line. X is greater than 2. Open dot or closed dot at 2? Open dot. And which way would I shade? To the right. So this is an example of an or inequality that you're probably used to seeing, where you have dots and then your arrows go out in either direction. So I would write my solution as x is less than or equal to negative 5 or x is greater than 2. So let's move on to the next one. Number 6. This is just another type of problem that you'll see. So let's solve this first simple inequality right here. Awesome, variable on one side, so I'm just going to solve for that variable. I'm going to do that by subtracting 2. 3x is less than 3. What do I do now? Divide both sides by 3. X is less than 1. So let's graph that on this top number line first. X is less than 1. Open dot or closed dot at 1? Open dot. Which way do I shade? To the left. Let's solve this other simple inequality. Variable on one side, awesome. All I need to do is use inverse operations to get that variable all by itself. So I'm going to add 1. And I get negative 5x is less than or equal to 10. And what do I need to do now? Divide both sides by negative 5. X is, what do? I divide it by negative. Greater than or equal to negative 2. I got to flip my sign because I divided by a negative. So x is less or greater than or equal to negative 2. So open dot or closed dot at negative 2. Closed dot. Which way do I shade? To the right. So these or inequalities, it could be this, x can be less than 1, or x could be greater than or equal to negative 2. This or that, it doesn't matter. So it's only the overlapping shaded region when you've got that and inequality. And an or inequality, either one of these would satisfy this compound inequality. It doesn't matter. So what would my solution really look like? All real numbers. All real numbers. It could be, your solution could be less than 1, but it could also be greater than or equal to negative 2. So your solution is actually all real numbers. That's that fancy symbol. It means all real numbers. You could also write it like this, your infinity symbol. That means infinitely many solutions. Because there are infinitely many solutions in this type of situation. Infinitely many solutions. So just pay attention to, sometimes you might see number lines that look like this. You might have an open dot, and your solution might be this right here. And this might be at the number 3, let's say. Your solution is all real numbers, but x cannot be 3, right? So it'd be all real numbers, but x cannot be 3. Sometimes you might see it like this, right? Well, it might be x could be greater than or equal to 3, and x could be less than 3. So if x is less than 3, but x could be greater than or equal to 3, well, now you're back to all real numbers. So just be careful whenever you see those kind of odd ones. All right, let's move on. Last one. Last type of situation. So this is another or inequality. So variable is on one side of the inequality sign. So all I have to do is solve for that variable. I'm going to subtract 6. Negative 4x is less than negative 8. When I divide both sides by negative 4, I get x is greater than 2. X is greater than 2. And if I graph that, x is greater than 2, open dot or closed dot at 2, open dot, shaded to the right. Let's graph the other one. All right, so I'm going to distribute this 0.5 or 1/2 into each term on the inside of the parentheses. 0.5x plus 1 is greater than 4, right? If I multiply something by 1/2 or 0.5, I take half of it. What do I do now? I'm going to subtract 1 from both sides. I get 0.5x is greater than 3. And then if I divide by 0.5 or divide by 1/2, it's the same thing as multiplying by 2. How many halves go into 3? 6. X is greater than 6. So what would that look like? X is greater than 6. So here's one of those situations where x could be greater than 2 or x could be greater than 6. This is not an and inequality, it's an or inequality. So what would your solution be? Therefore, your solution is x is greater than 2. It doesn't have to be the overlapping shaded region when you have an or compound inequality. So x is greater than 2, open dot at 2, shaded to the right. And that concludes your notes over compound inequalities. I hope it was a helpful review. I hope these different scenarios don't confuse you. You really have to think about what the words or and mean. So good luck.